Hi everyone, welcome to my YouTube channel. My name is Dr. Muntazir Hussain. In the previous two videos, I have shown you how you can download the Mentor Graphic SC 2020 software from Downloadly website. And in the second video, I have shown you how you can install and configure the licenses of Modelsim SC 2020. I will provide the link of those two videos in the description of this video. In today's video tutorial, I'm interested to show you how you can create as well as simulate a project in Modelsim. So for that purpose, I will write the Verilog code for NotGate. So in this lab, I will show you how you can create and simulate a project in Modelsim. So these are the steps which you require to be follow while creating, compiling, simulating, and generating the timing diagram of the design. The first step is create a Modelsim project and add file design file to it. For that, we require to follow the step number 1 to step number 7. The second step is to compile the project. The first step is to create the project, and the second step is to compile the project. For compilation, we need to follow the step number 8 to step number 10, and the third is to load the compiled project after successful compilation of the project. Next, we need to load the project for simulation, and for that, we need to follow the step number 11 to step number 12. And next step, we can add signal to the timing diagram in order to verify the input and output of the design. To see the result that the functionality of the design project is according to our desire. So for that, we need to follow the step number 13 to step number 19, and you can skip the step number 16 for adding timing diagram to the design. And the last step is just to run the project in order to see the result of the project. Now I will show you the step-by-step procedure for creating, compiling, and simulating a project. I would recommend that you should make a folder in your local storage where you can save all the design project, all the file of the design project. So for creating a project, just select file and then click new, and then from this pop-up window select the project. After clicking on project, this new dialog box will be appeared, and you can assign the name and you can set the location of the project, and furthermore you can set the library. So write the name that precisely describe the project. For example, in my case, I want to write the Verilog code for NotGate, so I have assigned the project name as inverted. Furthermore, you can browse the location. So browse that folder which you have created in step number 1, so that you can have all the file at one place. Leave the library work by default, and make sure that the copy library mapping is take on, and then click OK. So after clicking OK, this new window will be open, by which you can add the file to the project just by clicking create new file. So just click on this create new file. This new window will be appear where you can set the name of the file. So in my case, I have assigned the name of not_gate, and from this drop down menu, add the file type as well. So select the Verilog from this menu and leave the folder top level by default and click on OK. So you will see a new file will be added. For example, in this case, we do not have any file in the project. When you click on this OK, a new file will be added to the project. So as you can see in this case, a new file with the name of not_gate.v is added to the project, and this .v represent that the file type is Verilog file. You can add some more file as well just by clicking this create new file before closing this window, or if you close the above window, then you can add the file to the project later on as well just by right clicking in this project menu and click add to project, and then click new file. So you can add new file later on as well. So after adding the file to the project, the next step is to write the Verilog code for the design. So just double click on the file. In the workspace, this editable window will be open where you can write the Verilog code for the design. For example, in my case, I have written the Verilog code for inverter. So just start your Verilog code with the keyword module, and then assign the name to the design. For example, I have assigned the name inverter, and then you can assign the input and output ports of the design. For example, in my case, Y is the output and A is the input. So furthermore, it is important to note that you have to specify to the project that these are the input and these are the output of the design. So by using the keyword output and input. Furthermore, I have used the continuous assignment statement to assign the output to the input, and I have used the tilde notation in order to indicate the inverting operation of the NOT gate, and then and the module with the keyword and module. There are two methods. The first method is after writing this Verilog code, just compile the project and then click on simulation. You can simulate the project and add the waveform to the design, and further you can forcefully assign value to the signal, to the input signal, and you can verify the output signal. This is one method for testing the project, and the second method is to write the test bench Verilog code for each design. So you can write the test bench. For example, I have written the test bench for NOT gate. So here again, just start the design with the keyword module and assign the name to the test bench. So for example, I have assigned the name of NOT underscore test bench. And then in the test bench file, we define the output with the keyword wire, and we define the input with the keyword reg. And then you can call the previous module, that was inverter, and you can assign some other name to that instances. So I have assigned the name my not, and you can declare the input and output ports by two methods. The first method is by order, and the second method is by name. So I have declared the input output ports by order. By order, I mean the order of this instances should be the same as the order of the previous module. So as you can see, I have first declared the output, and then I have declared the input in this module as well as in the test bench. So the order of the input output port should be the same in both the module as well as in the test bench. So furthermore, you can assign some input signal just by writing initial and then begin, and then you can assign some value. For example, I have assigned the 1-bit value to the input, that is 0, and after 10 picosecond, I have changed the value of the input from 0-bit to 1-bit, and I have assigned some other values as well in the similar method, and then I have and the initial begin, and I have and the AND module as well. So after writing the Verilog code for the module as well as for the test bench, the next step is to compile the project, to compile the design. So just right click on that file and then select compile, and from the new menu select compile selected. So after clicking on this compile selected, this message will be appear, that is the compilation of your project is successful. If your code is error free, then this green message will be appear that the compile of not underscore gate.p was successful. If the project contains some error, then this red message will be shown that the compile of not underscore gate.p failed with one error. And then furthermore, just clicking on this red arrow, this new window will be appear, which will provide some more information about the location as well as about the type of error. So as you can see in this message, the location of this error is line number 6, and furthermore it specifies that the error is syntax error. So just by clicking on this new message, you will be directed to the location of the error. After successfully compiling your file in the project, the next step is to simulate the project. So you can simulate the project just by clicking, just first selecting the project file, and then click on this simulation from the above menu of the Modelsim, and then click Start Simulation. So after clicking Start Simulation, new window will be open, and then just click on the test bench of the design. Just click on that file which you want to simulate. Select that file and click OK. But make sure that this box should be unchecked. So after clicking OK, this new tab will be added to the project, that is Sim tab. And within the Sim tab, just select the test bench file and click right click on that file, and then further select Add to, and from this new window select Wave, and from this new window select All atom in the region. So after clicking OK, this wave window will be appear on your screen, which represent the input and output of the design. And as you can see that if the input is 0, then the output is 1. If the input is 1, then the output is 0. So the waveform, the functionality of the waveform is according to our design. That is the basic functionality of the NOT gate, that when we apply 0 at the input, the output is 1. When we apply 1 at the input, then the output is 0. So for creating, compiling and simulating your project, you need to follow these steps. Now I will show you the creation and compilation of project using Modelsim. So just open the Modelsim. This welcome window will be appeared. Just close this window, and then if you have already created the previous project, you can close those projects. In order to create the new project, you just need to click on this file. From the file menu, you can select new and just click on select project. So this message will be appeared. The operation will close the current project. So just click OK in order to close the current project. So as you can see, this new window will be appeared where we can assign the name of the project and we can set the location. So I will write the name of the project inverter. And I can browse the location where I want to save my project. Leave work as a by default library. Make sure that this option is ticked. So just click on OK. If you have created the project with the same name, then this message will be appeared. We want to override the project, so it will override the previous project if the previous project is created with the same name. So I have created the project inverter. The location is example. Furthermore, now I can add atom to the project. So just by clicking create new file, I need to assign the name of the file. So I will assign the name NOT gate. And furthermore, you need to select the file type from this drop down menu. So select Verilog and leave top level folder by default. Then just click OK. So as I said before that in Verilog coding, we usually add two files. The first file is the module file, that is the Verilog code, and the second file is the test bench code. So we will add another file with the name of _gate test bench. And again, I will select the file type Verilog and then OK. So as you can see, the two files are added to the project, and just close this window. And furthermore, you can add some more file to the project later on as well, just by clicking right click in this project window and then select add to the project and click new file. So the next step is to write the Verilog code. So as I have already written the Verilog code for the NOT gate, so I will just open my Verilog code. Just copy this code and then paste in the file node underscore gate. So I will just right click, select the file and then right click and then select edit, select notepad and OK, and I can paste the code which I have already written for the node gate and then press Ctrl S, and then you can close this notepad window. You can also write the test bench for your code as well. So I have written the test bench for node gate. I will just copy that code and paste in this node underscore test bench. So I will open this file as a notepad file and I will paste in this test bench and then press Ctrl S in order to save this test bench. I will close these notepad window. So after writing the Verilog code, the next step is to compile the project. So I will just first compile the module. Just right click on the file will be selected and then click compile, and from the compile menu select compile selected. So as you can see, this error message is appear in the transcript window. So just click on this message. This new window will be appear. As you can see, this indicate that the error is occur at line number 6, and the error is undefined variable. So I have used the variable a, which is undefined. So I will just click on this message. As you can see, this editable window is now open. So as you can see, I have declared my NOT gate. I have assigned the name of NOT gate using the keyword module. I have assigned the output, that is Z, and the input is A. I have declared the output is Z and the input is X, but I have used this A in this assignment. So this should be X. This is the error. So I will just close this error message and then I will correct my error, and then I will press Ctrl S to save the code. And now again I will compile my code using the same method. So as you can see that this green message is now appear after correcting my error, that is the compile of not underscore gate was successful. So now my design is successful, and furthermore you have noticed that I have question mark on this file. The status of the file is question mark, indicated by the blue question mark. When I compile my project, the question mark is replaced by green tick yes. So now I will compile the node underscore gate underscore test bench as well. So I will select that file and then again compile and compile selected. So as you can see, the compilation of node underscore gate underscore test bench was successful. So I have successfully compiled my project. So after successful compilation of the file, the next step is to simulate the project. So just click on this simulation and click start simulation. So as you can see, this simulation window will be open. From this simulation window, just click on this positive sign. So I will select node underscore gate underscore test bench from this menu and untick this enable optimization option and then click OK. So now you will see some new window will be added to the design. Just right click on the test bench and then select add to, and then the new from the new pop-up window select wave and then click on all atom in the region. So after adding wave to the timing diagram, just click on this wave, select this wave and then click on this run. So as you can see, the input and output waveform is generated in the timing diagram. To view this timing diagram, you can zoom in, zoom out, and zoom full the waveform, input and output waveform in the timing diagram. We can assign some different color to the waveform as well, just by clicking this waveform, and then you can assign some different color to different waveform. And then select the color and just click on apply and then click on OK. So as you can see, I have assigned different color to the input as well as output waveform. The output is Z and the input is X according to my design. When the input is 0, then as you can see, the output is 1. Now, if I move the cursor along the horizontal line, so as you can see, the value of the input and output is also changes. So hence, as you can see that the functionality is according to my desired. When the input is 0, the output is 1. When the input is 1, the output is 0. As we can verify this functionality of the NOT gate by this timing diagram. So in this session, I have shown you how you can create and simulate a project in Modelsim. I have written the Verilog code for NOT gate. In the next coming tutorial, I will show you some other basic logic gate, and then we will move to some advanced tutorial on Verilog hardware descriptive language. Thank you very much for your time. If you have any question or confusion, you may ask in the comment section. Please like, share and subscribe to my channel. I hope this is useful for you and hope to see you again. Thank you very much.